Okay, thanks to everybody for coming. I'm gonna go pretty quickly. I'm gonna break a few of the rules of presentation. I'm gonna try and do a live demo, which is, anathema to most. But bear with me. Hopefully, I'm gonna cover a lot of concepts that are, pertinent to everybody today. I'm not here to tell you what to do or tell you how to do it. I'm more or less gonna talk about bridging a little bit of the philosophy and different ways of approaching these problems, in the coming age of AI and agentic architectures and stuff like that, right? So it's a little bit like looking at the train that's coming down the tracks right at us right now, okay? So my name's Kirk Mower. I work at a company called Solstice Energy. It's in Hobart, Tasmania. We own and operate the natural gas pipeline down there. We retail natural gas. We also retail electricity. We're getting into biomethane, creating natural gas from recycled waste, and we're also going to be involved in some wind farm projects this year. So the data I'm working with, a lot of transactional stuff, a lot of metering and building applications at the moment. Okay, and I want to talk a little bit about philosophy of data, because I think if we work in data, we're all kind of data philosophers, right? Because we all are having to explain what does it mean to people. We're all the time explaining what the transactional data means and how it's going to get transformed into other formats that somebody up the level is going to try and say that has meaning to me, whether that's hard dollars or whether that's just some sort of KPIs that they want to measure, right? So we all do that, and that's, I think, data people are inherently kind of philosophical people in that regard. So that's kind of what I wanted to talk about. So I'm going to get into here. So traditional data engineering, right? We're talking about processing and isolation, bread and butter, right? We all do that, right? Let's do a transformation pipeline. Let's warehouse some data. Let's transform it, put it together. Do some CTEs. Do some views. Do whatever we need to do to get a consumable data set up to the analytics tier. All right, bread and butter. We all do that every day. So we have a lot of tools we can do that with. We have SQL, we have Python, we have Spark, we have, 1,001. I'm not selling anything, but I use a system called Mage, and I think it's really good. It's kind of, the guys at Airbnb did Airflow, and then the next guys in Airbnb have done Mage, and it's just, I find it really good. But I'm not selling anything today. All right, so yeah. So that's what we do, right? So now we're going to get into the philosophical issues, right? And again, I'm saying I'm going to move kind of quickly because I am. So this is it, right? 2011, Andreessen, software is eating the world, right? Jensen Huang, software is eating the world, but AI is eating software, all right? That's the world we live in. And last month we saw, I don't know if you guys saw it, but MIT Sloan Management Institute, they released a paper called Philosophy Eats AI. And basically what they're saying is you got to think about what you're doing before you do it, right? So you have to know, basically the purpose of what you're going to do. You have to know what counts as, real knowledge. What is that quality stuff, right? We talk a lot about data quality. We talk about managing data, data management, data governance. Right, so it's these sort of things, and we also need to talk about ontologies, how things are related to each other, and how those hierarchies work. So again, these are very philosophical concepts, but you probably do this stuff every day, but you're doing philosophy really, So that's kind of what these guys' paper is saying, and what they're saying is that once we start to get into an agentic architecture, that we need to think about these things before we go in, because the horses can bolt. If we're not actually giving an AI the correct context in order to perform the tasks that we want done, at the quality we want it done, and in the way we want it done, and served back in the way we want it served back, then we're going to take a lot more time using these tools, and it's going to be a problem. So it's basic common sense, but we're often presented, in our industry, we're often presented with tools, and we're told, because we have lots of salespeople telling us that it's a one-stop shop, It's a turnkey solution. It's going to work. It'll solve all your problems. And once you've been around the block a few times, you know that's not going to happen, right? So you still have to do the work. But now, in this world, we've also got tools like OpenAI, tools like Claude, tools like DeepSeek, where we can actually then use AI in our work to work faster. So we have a world now where we can work faster by utilizing these tools ourselves, and then we have a vendor selling us a solution. So you're weighing up this cost, right? Because now as a person, if you know the stack, you know the data, you know the interface, you know where it needs to go, you can cut code, you can cut SQL, you can cut an app with the help of AI very, very quickly. So then it's up to you to sort of decide, what's that, we have some people that are anti-roll your own, and then you have a vendor that is going to tell you to buy their own thing. But that's kind of the world we're facing right now. So those are the sort of things about the AI. And again, I've mentioned this paper. So these tools are very powerful, right? And if they're not being guided, they can and will go in the direction that their vector databases may take them, right? So they can shoot off and do stuff. So you really got to treat them like kids, and you've got to say, no, you're going to do this, and these are my rules, and these are my guidelines, and these are my, these are the rails you have to stay within. Right. So I'm going to get past the text now quickly, and then I'm going to go into some demos and some other stuff. So basically what we're saying is, my use case is, I've got the federal government, the Australian Energy Market Operator, provides electricity load data across the entire electricity networks of Australia. It's public data. That's great. So I can get it, onboard it, but then I want to do something with that. I want to predict load. So I want to predict what's going to be in the future. So those other elements about the future, I could go out and search for weather prediction data sets and onboard them. I could go out and search, for lots of different data sets and onboard them, and then write an algorithm and then tie those things together. Or I can go out to AI and do that. I can say, here is that sample set of data. This is the actuals from this historical period. It's summer in Australia, so you'd go and do the prediction, right, based on the sort of seasonal things and, other events that may be happening out there. There could be a game at the SCG, there could be, it could be any sort of factors that are going to create, a larger surge in power that maybe we don't know about, and we're not going to be able to onboard the data for that. But the big AI operators can do that. They can bring that in and augment your data with it. Again, lots of caveats, right? It's always buyer beware, but lots of power, power can be used for good or bad, et cetera. So this is kind of what we're talking about, and I'm kind of, about the bigger picture, right? So AI systems, right, we can go pattern matching, and we can say, do this. And again, but if you're giving things more context, you can get into, a more detailed response that then you can bring back into your systems, right? So this is just one thing that's giving you a richer response by providing it context. So here's one. This is an example of data. So this is a data pipeline. Basically, very simple, right? Go and get this data, download the data, transform it, and slam it into my data warehouse, right? Bung, 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 right? Very simple, right? And we've all seen this stuff. I'm going to jump out, show you a little bit about this, and this is it, right? So I can go in here. This is where that data comes from, and basically we can get in here and we can find the controlled load profile, and God bless our government, they provide it as XML files, right? They don't give it as data. So we've got to write the routines. They go and grab the XML files and the zip files, download the XML files and the zip files, read the zip files, and then parse them into the database. Data engineering 101, right? Like bread and butter stuff. Great, awesome, because we need the data, right? Then I've got my data source, and that's all I'm trying to say. That's great. That's never going to go away. So that's, that's what you want to do. So this is what this does, right? And that's about it, right? So but you're at that point of saying, what am I going to store myself and what am I going to access elsewhere? So some of those things you're going to have to go and do the traditional data engineering for. Some of these things will be on tap. Some of these things will be exposed to you as a source, right? Storage is cheap, but going after it and onboarding it can be, it's just extra steps, right? It doesn't have to be hard, but you have to find it and you have to find out how to run it and how to do that stuff. Okay, so this is that data, right? This is a snowflake table with the Australian electricity network load and load data, all right? So I've gone out, we've parsed those files and we've slammed them into the data warehouse in the AMO network load new table, right? And then we have, you can see stuff here that's got, this is basically 5-minute load profile. So the smart meters in Australia, they are metering, if you have a smart meter, they're metering your data at 5-minute intervals. And then what the Australian energy market operator does is they aggregate all of those intervals for each region, and that gives you a picture of that load. And then this is the data that I've parsed. So I've got, I don't know, what is your energy provider here? You've got, I don't know, I know mine's Aurora. We've got Ergon, Power Core, Country Energy, Integral, United. You kind of need to know what area you're in. But that's it, right? So that's the raw data. Great. So then what are we going to do with that? So I can take that then, use that data in my profiling, or I can go agentic, right? So what do we mean by agentic? So what they're doing, what all of these LLM systems are doing is they're eating a lot of data, they're vectorizing it, and they're storing it for you, and then they have all those relationships to say closest neighbor and what is the meeting and the semantics. They do all that for you. They make it very easy. So that, they're eating all of this information all the time. So, so it's an arguable question, like, what do I need to onboard? Well, you need to onboard, what you need to have is your own data from your own company, clearly. Beyond that, that's where it's starting to get a little bit hazy, is all I'm saying. So you've just got, and then you can use things to pull that data in and match it with your data. And that's where we come into this sort of, you've got, this is the agentic anthropic model, basically where you can go out and do a multi-agent search, right? Instead of RAG, which is doing a one-shot, multi-agent now is going to go, you provide it more context, and it's going to spawn off sub-agents to get more information and augment that data for you. You're not going to build that yourself, right? These guys have got billions in venture capital, and they're the ones eating all that data. So that's great, right? You can use Claude Desktop, and you can do that as a one-off, right? But then, if you're pasting your data in, that's problematic. Single user, it's great. That's how you get started, right? So then from there, and this is what Anthropic is saying too, right? So you're basically the difference between multi-step search or multi-agent now is very different from RAG. Last year, everyone was talking about RAG. Take your documents and vectorize them, and then I'll understand your language. Okay, great. But how much of that do we need to do, right? And how much of that do we need to pay for being done in the documents? So if we are the data people, and we can access that language model elsewhere for cheaper, we can do that, right? We don't necessarily need to RAG all our documents, right? Unless we're trying to do some amazing enterprise search stuff, which has been done. So from there, we get into this multi-context protocol stuff. So MCP is an architecture where you're going away from the desktop application and you're going into more of a microservices or service-oriented architecture. So all the MCP server is doing is it's connecting, think of it as it's connecting to your data source. It's kind of a controlled version, of saying, all right, feed them this data, you can do whatever you want with that data. You can de-identify it, you can do whatever, and then you pass that to an agent to work with. And then you can publish that, and other people can publish theirs. So you have this sort of ability to say, what I have, I'm exposing data, and this is what that data can be used for. So this is, I think, that train that's coming down the tracks at us. And it's very powerful, right? And it's making us question, what we're going to do. Where are we going to run workloads, and where are we going to offload workloads to one of these larger AI players? Because they can do a lot for us without us necessarily having to do the first principles work. It is fraught, there can be issues, but that's kind of the issue, right? So you can then use the thick client to do this stuff, or you use your app. So you can roll an app, and you can say, right, great. That will actually then be integrated with a larger LLM, and you're passing it your data in a controlled fashion. So that MCP server could de-identify your data on the way out to get rid of all those PII and security issues that you're going to face, right? But it can then come back in, right? So then it'll do something for you, right? Whatever that task may be, whether you want to do prediction, or whether you want to do some sort of stochastic gradient descent even, or even write a piece of code based on your data about what you want to do. Right, you can say, because the corpus is very large of, say, something like Python or even SQL, the AIs know that stuff very, very well. It's not perfect, but it's very good. So you can say, go and write a piece of code based on this, and then it will come back with that. It'll be probably about 90, 95% correct. You probably have to tweak it a little bit, but it's going to get better, right? And again, this is the saving time, doing things faster sort of thing. So I'm going to show you this demo a little bit, right? I just rolled a little demo just to do this, so I'll show you that. So basically, I've used AI to do this. I make sure I connect my MCP server. Boom, okay, I'm connected. I got 6 MCP tools. Okay, great. All right, get my load data from here to here. Right? Okay, which profile? Nah, it's just a 5-minute. Okay, yeah, and I'll do Aurora. Right, okay, good. So I got 5-minute load across Tasmania. Bonza, right, great. I mean, I have used AI myself to create this app, right? I know these languages, so I can do this stuff quickly, but I was able to create the MCP server, create the client, and create even the little application, pretty darn quickly. So this is not a productionized thing. This is basically me doing the exploration. So what does this stuff do? How do I use it, right? Like, is it going to give me anything good, right? And then I can say, okay, great, let's look, thank you very much for that. And then I can go, let's go to peak load analysis, right? And then it'll give me, I can do this as data, but now it's just giving me a text-based description. But you can sort of get the idea, right? Based on this, daily data patterns around 8 to 9 a.m., right? So it's giving you sort of a feel for it, but there's no reason why it can't also process the data, right? Same thing for predictions. You can say, right, okay, I'm gonna go for my area. And I'll go, yeah, give it to me for a week, right, bang. And it's gone, yeah, okay. So peak demand will reach 1450 during the hour, 6 to 7 p.m. based on current weather forecasts and historical patterns. Morning peak should be around 1,180 megawatts, right? Overnight minimum loads are expected around 65 megawatts, 650 megawatts, right? So, and it's telling you what are the key factors influencing these predictions, including moderate temperatures, reducing cooling loads, typical weekday commercial activity, yada, 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 right? So you can take this is sort of, almost horoscopy stuff, but you can take this and turn this into data is, I guess, my point in terms of doing a demo with it, right? And then you can also do this sort of thing and say, all right, yep, let's generate the prediction, right? And then it's gone and generated a prediction of load with a confidence level, right? I've had to do very little to get this done, right? And this is an app, and I'm not using Claude itself. It uses the Anthropic, API, and this is just a web app that goes out and does that, right? Pretty simple, right? But my point is, that's my point, that you can do this in the language of your choice now, quickly and easily yourself, so you can get out there and explore this stuff, right? And then you don't need to get caught up too much in productionizing it and seeing what's happening, because the industry's coming to you, right? They're trying to come, everyone's competing and fighting and doing all this stuff to get it better for you. So you know that's coming, right? Your use case is like, okay, well, how do I use it in my job, and what am I going to do with it? So that's where you're in a position as a data person to perform that role. Say, well, we've got this data, you could do this, that, and the other. Or someone said, oh, can you do this? And you're saying, well, yeah, we could, but it's going to be this, it's going to be a sort of plus or minus 30% prediction. Is that good enough, right? So then you're surfing the sufficiency model, right? You're talking to the business about what's good enough, for their needs, right? So that's kind of, this is what I'm talking about, things like philosophy. Cool. Moving fast. Right. Cool. Again, I could show you the code for this, but it's not, it's not too, it's really not, in your language of choice, basically, you're going to have a bunch of tools. You have a bunch of functions. You can define the queries that are grabbing the data. You can define where they go. You can define how they go there. And you can define the context by which they go there, right? Saying, you are an expert in this and you're going to do this. So you have that control as a data person to say, I know where the data's coming from. I know how to describe it. You could pull the metadata in and augment it with this, and then I know what I want to do with it, and I'm going to pass that on. I can expose that. So you can, as a data person who's close to the data, you're the critical element, because you need to know the starting point, and from the starting point you can get to different endpoints, but it's critical to know the data in the first place. All right, and so that's the idea. So you've got, you're getting this sort of richer information that is, you've got augmented by different data that you're not necessarily storing, right? But, and the big but is there, we still have to do the thinking about what we're doing, why we're using these tools, and what is defined, what we know, what we don't know, and what our data quality is. So all these, all that stuff you've been doing for years just puts you in that position to be the person to advise on these things, right? Because you've already done that thinking, and you've been doing that thinking because you've had to. So you're really placed well to continue doing it as these paradigms change. Right, and then you can get into things like orchestrating. So that was a standalone application, right? You can imagine. Then you could sort of say orchestrating, right? So then I could say, then we can sort of get into these sort of frameworks where you're saying, right, you set up your YAML file or your environment variables, and you say, extract this from this warehouse, do this with this AI engine, run the code over here on this compute, and then use this visualization engine to display it to the user, right? So that, that sort of thing. And then, basically that's my little, ChatGPT created server farm orchestrator, right? And you can set that on a schedule, run your cron job, or run it daily, or run it weekly, or whatever. And then you could then start to then pull in different quality metrics of those data sets, right? Because then you can have the agent push it into your data catalog, right? I've created this data set today, and it was on this stuff, it was on this data from, this state to this state, and it was using this context, and it was, this was the quality rating that came back, bang. So it's just another, storage is cheap, bang, you can create another data set, right? And then when the actuals come in, you can start to do that sort of A/B testing to see which one's the better way to go, right? Which one is creating the best results based on the reality. So you can do the stuff that we've done, like for yonks, but I'm just saying it's a lot. You can do things, suddenly you're doing things faster, right? And that's the acceleration that I believe this stuff is giving us, right? And that's kind of, that's my analogy, right? So we have like imperfect analogy. This is the Industrial Revolution stuff, right? We have the weaver weaving, and you've got the programmer doing his data pipelines, right? And you're an expert, right? You're doing it by hand. You know how the bob rolls, or you know how this bit of, how this script affects this. You know how the Kubernetes cluster works. You know how, right, that, you know how that SQL works. You know how that CTE works. You know where the transformation is occurring, right? And you're doing all that by hand, to moving into the other analogy, where you're in the factory and you're supervising a lot of the workers on the machines, say producing a lot more fabric, as or the programmer or the person at the coal front who is deploying all the agents at their behest to get the job done. So then suddenly you've got a lot of workers who can do this stuff, and as being able to know it and orchestrate it and vet it and quality control it, you are then more productive. Productive is a two-edged sword, right? Productive means you do more work, right? You have to work, right? We all have to have jobs. If we're not super wealthy, we're not Elon, so we have to work. But you're in a good, all I'm saying is, as a data person, you're in a good position to do this work, right? In terms of taking your jobs, right? And this is kind of the thing, right? This is from the Wall Street Journal yesterday, right? And they're saying CEOs trumpet smaller workforces as a sign of corporate health, right? And they're saying that AI is the reason, right? So knowing the data, knowing how to orchestrate things that get done to the data, knowing how to store it, knowing how to know the metadata, knowing the quality that happens, that gives you good job security, right? That means you are the people that you want to be hired, right? That's good. So it's not necessarily bad for you. Yes, there are going to be less jobs, but if you've got the experience now, that's great, because then you're able to, I think you're in a good place to make the paradigm shift. Okay? So that's kind of what I want to wrap up with. You've got these possibilities for architectural, evolution, right? And then you've also got some, tightly coupled, and then you can go agentic and loosely coupled, very similar to some of the language, of the past. And then there's sort of Ali Ghodsi, who's the CEO of Databricks. He's saying, choose the right engine for the right job, right? Very competitive, right? If my engine is better than yours and cheaper, use mine. If his is better at doing that and cheaper, use his. And that's, a lot of vendors don't want you to do that, but going loosely coupled allows you to do that. And this is kind of where we get into vendor bashing, and we can say, they're going to try and sell you this stuff rolled up and packaged. That's a corporate reality, because people are going to want to do this stuff. The C-suite wants to do this stuff. They want to throw some money at it. But you have a lot of power to do this stuff now, and you can then do these rapid prototypes for people now, and you can do a bake-off now, quickly. So you can do these things like that. I did that thing with, part-time within a week while doing my other job. So you can do it, right? And that's, and then you really can give them a cost-benefit analysis of apples and apples to compare, right? Because do you really want to pay $100,000 for that, or $1 million, or whatever, or can you augment, right? So that's, because like I said, burn, baby, burn. They want you to burn credits, they want you to burn compute, they want you to spend more money. This is also, if you've watched The Smartest Guy in the Room about Enron Corporation, which was the power trading corporation in America that went bust and huge financial problem. They had electricity traders on the phones when there were fires in California saying, burn, baby, burn, because those fires in California were taking down power lines, and the trading price of electricity was going straight up. So the electricity traders did not care about anything but the money. All right, so who's going to be running these workloads? Who's going to eat whom? Right? This is a competitive world. Is Anthropic going to eat Snowflake? Is OpenAI going to eat Databricks? Maybe that's going to happen, right? Maybe they'll buy them, and then your warehouse is on, is with the AI guys. You don't know, right? It's a competitive world. So a bit funny, but that's my shtick, right? So I'm going to wrap up now. That's just it, right? AI agents, they're coming. We can't really avoid them. We've got a few caveats. You guys are empowered to do the thinking because you've already been doing that thinking for a long time. So really, I think, in terms of not worrying about losing my job or whatever, the idea is to say, you're on the wave, you're riding the wave, you're in a good place. And utilize this stuff, have a play, do experimentation, and make sure you're not saying, I've got a hammer and every screw looks like a nail, because you don't necessarily have to do it the way you're dictated to. You can use any language you want to achieve any means you want, and you have your friend, an AI who knows the corpus, who has all that stuff defined. They can help you. It can help you do all that. So that dogmatism around saying, I use this language, I use that language, it's better than that or better than that, doesn't really matter, because you can generate it in your language of choice, right? So it becomes a cost issue and a compute issue where you're going to run that stuff. So to give yourself freedom of choice rather than being sold a pup. And that's my presentation.